Hello there, this is Mr. Benji again. In this tutorial, I will demonstrate how to solve problems on the topic of scientific method. Scientific method. This is more of an introductory conversations, especially early in freshman psychology, foundational concepts in helping us understand how and why the scientific method is the best method, is the most productive method when applied to studying human behavior. It is such because it is the best method. It is pretty much the only method that holds the power to help us obtain generalizable information. Okay? Again, the idea is about generalizability. Okay? It's not necessarily that the scientific method is superior over other kinds of other ways of knowing such as tenacity or authority or intuition, the rational method, the empiricism, the emphasis on experiences. Not that those strategies are not possible for us to go from not knowing to knowing. It's more that the scientific method holds a higher level of power to minimize and perhaps even eliminate bias so that information is generalizable to as wide a population as possible. Take a look at this first problem here. Professor Harjani was skeptical about the accuracy of a recently reported research on exercise deprivation. Which of the following processes would best enable her to assess the reliability of these findings? Now, what you might want to pay attention to is the subject matter. Let's start by evaluating the subject matter. Professor Harjani, this professor here, and it doesn't really matter what name we use for the professor, the instructor, the scientist, the researcher, it doesn't really matter. So don't get hung up on the specific names given. Okay? So the topic of interest is, as indicated, exercise deprivation. A situation where people lack exercise. When people do not engage in sufficient levels of exercise to support their sense of well-being. Which of the following processes would best enable her to assess the reliability of these findings? How exactly do we increase? Okay, how exactly do we assess as well as to increase reliability? Again, the idea of reliability keep in mind that reliability describes how consistent a tool is in its measurement of a trait, of something, of anything. We would describe a thermometer, for example, as carrying a high level of reliability if every time when used to measure temperature, it gives exactly what the temperature is. It doesn't change its measurement when measuring essentially a space, a room, for example, which the internal room temperature is consistent. Okay, so it's the consistency of measuring accurately that which we intend to. The consistency in measuring that which we intend to. Now, one way to establish consistency, as you can imagine, for something to be interpreted as consistent, it does not change from the first time to the second time to the third time to the fourth time to the fifth time to the nth time. To the nth time. That is to say, there needs to be more than one measurement. We need to measure the same situation. We need to measure the same situation under similar conditions more than once, right? So the idea of consistency can only be established by doing the same thing more than once. Right? That's the issue of reliability. Now, the idea of more than once, as the correct answer is indicated here, to replicate is to do the same thing again. Okay? To replicate is to do the same thing again. Therefore, it's no surprises. Okay? It's no surprises that answer option C is the best answer. The idea of doing the same thing again. Scientifically, what you might want to think about is this. What you might want to think about is this. Be reminded of a general three-step process when thinking about applying the scientific method in a research setting. You can always think of the first step as putting together a hypothesis. What exactly is a hypothesis? A hypothesis is an assumption. It is an assumption. We're considering certain idea, and we, to begin with, assume that the idea as true. And based on this assumption, we would then move on to construct the research procedure, a set of steps constituting research procedure to study and to see if the idea is true, to see how true it is, the extent to which it is true. Some ideas, depending on the specific research question, they can hold a stronger level, a higher level of strength of truth than others. And the third step is, after taking through the research question through the steps set out in the research procedure, we would come up with certain outcomes or results. And if the results and outcomes, and in many cases, results and outcomes are captured using numbers. Once captured using numbers, after taking the numbers through some levels of analyses, we may come to the conclusion, for example, if we obtain outcomes that seem to confirm the hypothesis, assuming that they confirm the hypothesis, then we now have a situation we can begin to formulate a theory. Now, this theory, to begin with, if we've only looked at, in a scientific fashion, the hypothesis once, while the theory may or may not, well, it's not necessarily an inferior theory, however, to increase the strength of the theory, to increase our level of confidence that what the theory says is the truth or describes reality accurately, we might want to consider replication. We might want to consider doing the same thing over and over and over and over again. Hence the idea of replication. Okay? Replication increases the level of reliability. Replication also assesses how reliable certain findings are. If we go through the same set of research procedures again, and obtain similar results, well, we assess that the reliability is high. That's the language. That is the language. Now, random sampling supports reliability, yes, because random sampling reduces bias. Do you see random sampling reduces bias? So random sampling is not a bad answer, okay? It's not a bad answer. Sample size of 5,000 or larger. Neither is this a bad answer because the larger the sample size, the more representative the sample size is of the wider population. That is to say, we can generalize our findings more confidently to the entire population. The larger, the more representative. Okay? Again, this is not exactly a bad answer per se, but compared to replication, replication holds a higher level of power because by reliability, we're concerned about, well, two levels. One, the findings themselves, and two, whether or not the method we've designed to measure measure the traits, measure the factors relevant to exercise deprivation. We want to ensure that we're measuring the right thing, and to measure the same thing more than once is of utmost importance. Okay? It's of utmost importance. Now, there are two other options here which we'll quickly evaluate. The case study, not a good answer. Naturalistic observation, not a good answer because both the case study and the naturalistic observation, these are strategies when it comes to the level of research we refer to as description. And in descriptive research, all we intend to do is to make observations and to describe what's happening. And simply by describing exercise deprivation, we don't really learn a whole lot about deprivation. We don't really learn a whole lot of the dynamics underlying deprivation and why deprivation works in such a way, or the reasons exercise deprivation influences various different other aspects of life. We don't learn why, and hence there is nothing to measure really. There's nothing there really is not anything to measure per se. Okay? Hope this tutorial helps. And again, nothing is in the way for you to rewatch the tutorial and gain further clarity and mastery of the subject matter. More of such will be made available in the foreseeable future. Hit the like and subscribe buttons to stay up to date of quality tutorials that can help you succeed in your studies. You've been watching Mr. Benji and Mr. Benji Now on YT, YouTube. I'm a college instructor in Vancouver, BC, Canada. Until next time.